Class 12 Physics, chapter Your Current Electricity. In previous video, we have discussed about what is drift velocity and expression of drift velocity we deducted. The expression of drift velocity Vd equals to E, that is charge on electron. Capital E represents electric field provided to the conductor. Then m is mass of electron and multiplied by your mean relaxation time tau. So this expression we deducted already. In this class, we are going to see what's the relation between current and drift velocity. For this, let us consider a conductor. Here it is a conductor and battery is connected. This is positive terminal, this is your negative terminal. In that case, current flows through the conductor and direction of electric field from positive to negative. This is the electric field from left to right in this case. So in order to establish the relation between current and drift velocity, let us consider a portion of the conductor. Say this is your conductor and from here a part of conductor we have considered. Here from P to Q and length of PQ, suppose L. Suppose this is a conductor, a small part of conductor we have considered. The length of the that part is your L. So I have written here A is the cross section of this PQ, a portion of the conductor of length L. This length is your L. N number of electrons per unit volume. Remember this small n, it's not the total number of electrons. It represents number of electrons per unit volume, or you can say electron density. Then E, by this letter E, we represent charge on an electron. We know charge of an electron is 1.6 10 to the power negative 19 coulomb, but that charge we are going to represent by small letter E. Vd is your drift velocity. Now you see, what is current? Current is rate of flow of charge. That is I equals to charge divided by time. That's known to us. So first of all, let us do one thing. Let us try to calculate volume of this part. Volume of this part. Volume of this part. Because per unit volume number of electrons known to us. That is your N. And if we can find out volume of this part, so multiplying by E, you will get total number of electrons in this part. Let us do this. First of all, volume of the portion PQ equal to, that means volume of this part. Say this is your cylinder, it's your cylindrical part. This length is your L, and if I keep it like this way, you will say this is your height H. And volume of a cylinder formula is your what? Pi r square H. And if I keep it like this way, the same height, you will say it is as length. In that case, what is the volume? Pi r square into length. So pi r square is what? Cross section area. So you can say volume of this cylinder cross section area multiplied by the length. That's why volume of this part will be your what? Cross section area A multiplied by length L. So let me write volume of the portion PQ, that is your A times L. This is your volume. Now see, after calculating the volume as AL, then per unit volume, what is the charge? Electron density is your N. N is number of electrons per unit volume. Therefore, you can say total number of electrons. Total number of electrons. Where? In this part, in this portion. That's your N times A L. Right now, what's the total amount of charge? Charge of one electron it is denoted by E. Therefore, charge in the portion PQ. In this portion, right now, your amount of charge is your number of electrons, total number of electrons multiplied by charge of one electron. That is your NaL times E. So total charge you have calculated. Now you see, say right now this amount of charge is present here. Say it takes t second to cross this cross-sectional area. That means in time t second, say it passed through this. Therefore, current I will be equal to NaLE, total amount of charge present inside this, and in t second it crosses this part. Then current through this at this cross section, charge divided by time t. Now you see, this will give you I equals to, let us do one thing. Here NaE as it is, and L by T into L by T. We can write it like this way. Then what is L by T? L is, you can say, distance from Q to P, and T is your what? Time. Then distance divided by time. It is displaces from here to this. From this part, it displaces in this side. So distance is your L, time is T. It's nothing but velocity. And which velocity you have to consider? Because the electrons have a average velocity that is known as drift velocity. That's why this L by T is nothing but your drift velocity. So finally you can write I equals to NaE V D. This is the relation. So finally I equal to, you can write it like this way, VD E N A. This is the relation between current and your drift velocity. And you can remember it. You can design your own technique. But if you say I equals to B na, that way also you can remember. See, we have already established the relation between drift velocity and your current. Or you can say current between current and drift velocity. This is the relation. Now, let us establish some other relations. Say, if I want to know what's the relation between current and electric field, E. So, for this, the first relation, we already established that drift velocity expression Vd equals to charge on electron, electric field divided by mass into mean relaxation time, tau. Now, if I replace it here, then I reduces to what you see. I equals to, let us replace the value, E by M into tau into ENA, that is charge on electron, then electron density into cross section area. So then what you get, this will give you I equals to your N E square cross section area and then tau times electric field divided by M. This is one of the relation and one expression to find out current when electric field, or you can say relation between current and electric field. Now in second case, now we are going to introduce some terms. First is your electron mobility. What is electron mobility? Electron mobility of free electrons is defined as the drift velocity per unit electric field. So it means, say, electron mobility, it is denoted by mu e. it is nothing but drift velocity of free electrons per unit electric field divided by E. That's it. This is your electron mobility. Now you see, from here you can say then drift velocity is nothing but electron mobility times electric field. This is another expression of your drift velocity. Now say if you want to know electron mobility, that is your mu E in terms of average relaxation time tau, then what's the expression? Simple, Vd is known to us, that is drift velocity expression known to us. So here Vd is what? Vd is your E divided by m times tau. So simple, replace the value here. Then it is your E over mass of electron tau equals to mu E times E. Then E cancelled out and you will get, let me write here, mu E is equal to, what is left here? E tau by m. E average relaxation time by mass of electron. So this is electron mobility you have written in terms of relaxation time, or you can say average relaxation time, or in terms of simply you can say tau. Then one more expression, let me write here. Say current I in terms of electron mobility E. Then it will be, as you know, I equals to your V, D, E and A. This expression just we derived. So this is your relation between current and drift velocity. Now you see, here E and A make it in one group into, just now you have obtained that drift velocity is electron mobility times electric field. So mu E times electric field. And from here you will get current I equals to NEA mu E electric field E. And this is the expression of current in terms of electron mobility. So these are important expressions, and in a systematic way, let me repeat once. At first, electron mobility, it is nothing but drift velocity of free electrons per unit electric field provided. Say electric field provided E, then drift velocity of free electrons, that is your, electron mobility of free electrons Vd by E. From here you will get expression of drift velocity, that is electron mobility times electric field. And then electron mobility mu E in terms of tau. Simple, just you have to replace this drift velocity. That's why drift velocity Vd equals to, known to us, E by m into tau. So that value we have placed here. E cancelled out and you will get mu E equals to u tau by m. So this is the relation, or you can say electron mobility in terms of tau. After that, say current in terms of mu E, or in terms of electron mobility. For that, simple, write the relation between current and drift velocity. This is written, and just you do one thing, replace this drift velocity, which is your mu into E. So mu into E replaced, you will get the relation between current and electron mobility. I hope all these steps are clear. Thank you.